Welcome in Kuzi La. In the Kingdom of Bhutan, high in the eastern Himalayas, rivers are not only sacred, they are lifelines. Flowing from the glaciers of the tallest peaks, they carve deep valleys and thunder through gorges. These rivers give Bhutan not only beauty and life, but also energy. Clean, renewable energy. In this film, we explore the Tala hydropower plant, one of the Bhutan's largest hydropower project, and discover how water from the mountains is transformed into clean energy, economic strength, and a brighter future. More than just a dam, it is a marvel of engineering. Bhutan's steep terrain and fast-flowing rivers make it a natural powerhouse. Hydropower is the backbone of the country's energy system, contributing over 99% of domestic electricity. It is also Bhutan's largest export, strengthening economic ties with neighboring India and supporting the nation's development goals. Among all the hydropower projects, one stands above the rest, the mighty Tala hydropower plant. The Tala hydropower plant is located in Chukha district, on the Wangchu River. Wangchu River is made of three major river tributaries that are Hatsu, Patsu and Thamtsu. With an installed capacity of 1,020 megawatts, it is the single largest power station in Bhutan. Construction began in the late 1990s with technical and financial support from the Government of India, and by 2007, the plant was fully commissioned. Tala's completion marked a turning point in Bhutan's energy history, scaling up electricity generation to new heights. The main components of the project are concrete gravity dam 92-meter high and 130-meter long located at Vanka. 3D silting chambers each 250 meters long, 13.9 meters wide and 18.5 meters deep. Modified horseshoe-shaped head-raised tunnel having 6.8 meters diameter and 23 km. 184-meter high SO shaft. 2 pressure shafts. 6 penstocks. Underground power station. 206 meters by 45.5 meters by 20.4 meters. Which houses 6 turbo generators of 170 megawatt capacity each. Tail race tunnel 3.1 kilometers long. Underground transformer cavern 191 meters by 27 meters by 16 meters. Interlinking substation at Malbus. 2 double-circuit 400 kV transmission lines from Tala to Indo-Bhutanese border of 140 km length. So, how does Tala generate electricity? A concrete dam is built across the Wangchu River. Instead of storing huge water like in big reservoirs, the dam diverts part of the river into intake tunnels. The dam also has spillways to release extra water during monsoon floods, so it doesn't overflow. Headrace tunnel. After intake, the water flows into a headrace tunnel. Tala's tunnel is around 22 kilometers long. The tunnel carries water deep inside the mountains, toward the power station. Purpose: bring water from the dam to a point much lower downstream to create a huge height difference. Surge shaft. Before dropping down, water passes a surge shaft, a vertical chamber. This controls pressure changes when water flow suddenly increases or decreases, prevents damage to tunnels and turbines. Penstocks, pressure pipes. From the surge shaft, water enters penstocks, large steel pipes. These pipes carry water steeply downhill to the underground powerhouse. Because of gravity, the water gains tremendous pressure due to the head of about 860 meters, almost a kilometer drop. Powerhouse. Tala's powerhouse is deep inside the mountain to protect it and save space. Inside are 6 Pelton turbines, each 170 megawatts. Why Pelton? Because Pelton turbines are best for high head, low flow water, like in Bhutan's steep rivers. High-pressure water jets strike the turbine buckets, spinning them at high speed. Electricity generation. The turbine shaft is connected to a generator. As the turbine spins, the generator converts the mechanical energy of water into electrical energy using electromagnetic induction. Tala generates about 1,020 megawatts at full capacity. Step-up transformer and transmission. Electricity produced is at 11 to 15 kilovolts, low voltage. Transformers step it up to 400 kV for long-distance transmission. Power lines carry electricity to India, mainly West Bengal, through high-voltage transmission networks. Trailways tunnel. After passing through turbines, the water, called tailwater, is released back into the Wangchu River downstream. This way, the water continues its natural flow, No wastage. For animated explanation for the working principle of hydropower plant. After the dam is built, the flow of water in the river is restricted and water builds up to form a reservoir. The water from the reservoir is concentrated and flows through intakes past the control gate that controls the force of the river's flow and into the dam. From the control gate, the water current passes down the pinstock and over the blades of the turbine. The water pressure here is extremely powerful. As water is pushed over and through the turbine, the force of the compressed water is strong. It rotates the blades of the turbine, which in turn spins the generator. The water flushes out past the turbine, through the outflow and into the riverbed to continue its journey to the sea. The generator contains many strong magnets. As opposite poles of the magnet spin rapidly in the generator, electrons are cast off and captured by heavy wires in the powerhouse. Huge transformers in the powerhouse convert the electricity to the correct voltage so it can be used by everyday citizens. Power lines carry the electricity over many miles to cities and towns, businesses and homes. How does rotating of turbine generates electricity? As the fluid moves, it exerts force on the turbine blades. This force causes the turbine to spin, converting the kinetic energy of the fluid into mechanical energy. The turbine is connected to a generator. As the turbine spins, it rotates a shaft connected to the generator. Inside the generator, coils of copper wire rotate within a magnetic field, which induces an electric current through electromagnetic induction. This process is based on Faraday's law of electromagnetic induction, which states that a changing magnetic field within a closed loop of wire induces an electric current. To talk about the benefits of Tala hydropower plant. The Tala hydropower plant is more than an engineering wonder, it is the heartbeat of Bhutan's economy. Every year, Tala generates billions of units of electricity. Much of this power flows across the border into India, where it lights up homes, powers industries, and supports regional development. In return, Bhutan earns hundreds of millions of dollars in revenue, which directly funds schools, hospitals, and rural development projects. For Bhutan, a small nation with limited industries, hydropower is a lifeline. It accounts for more than 30% of government revenue and nearly 40% of national exports. Environmentally, Tala plays a vital role in keeping Bhutan carbon negative. By relying almost entirely on renewable hydropower, Bhutan avoids burning fossil fuels, preventing millions of tons of carbon emissions. But hydropower is not without challenges. Large projects like Tala involve tunneling through fragile mountain terrain, raising the risk of landslides. River ecosystems may be disrupted, affecting aquatic life and traditional fishing practices. Engineers must balance electricity generation with careful environmental stewardship. Still, Bhutan remains a global example of how a country can grow sustainably while protecting its environment. Looking to the future, Bhutan's hydropower journey is far from over. The country has an estimated potential of nearly 30,000 megawatts, yet only a fraction has been tapped. Projects like SANGAY, which aims to be the largest reservoir-based hydropower project in Bhutan, and Kolongchu, a joint venture with India, are on the horizon. These will further boost capacity, revenue, and regional cooperation. But Tala will always hold a special place. It is more than a power station, it is a milestone of engineering, a cornerstone of Bhutan's economy, and a symbol of partnership between Bhutan and India. As Bhutan continues to balance tradition with modernization, Tala reminds us of a simple truth: energy can come not from smoke and fire, but from the pure, rushing waters of the Himalayas. For Bhutan, hydropower is not just electricity. It is growth. It is sustainability. And it is happiness, powered by nature.